in the synthesis of carbamates out of carboxylic acids. Therefore, I draw my reaction structure with substrate and product. Draw the reaction arrow in between to define reactant and product automatically. Click on OK and can submit my search. You see that I retrieve 2 as drawn results, 100,000 substructure results, and also about 1,000 similarity results. I'm specifically interested in the substructure results, and opening these, you actually will see immediately that the hit doesn't seem to be fitting exactly what I've drawn. However, you see highlighted, comparing to the query, relevant hits. So the system searched the substructures of the substrate and the product, and this is a valid hit to what we've drawn. So the system is not doing anything wrong, it just doesn't know what you actually wanted. So what we can do now is to tell the system what we really want to have, what be searched. So we can mark the reaction sites with that arrow having the 2 lines. So this bond is now marked to be formed or changed during the reactions, as well as the bond in the substrate shall be broken. Additionally, we can also map atoms. So here we can say this carbon atom shall later on be exactly this carbon atom in the product. And with that, we can resubmit our search. Click on substructure. And you will see that we already got much less reactions. Scrolling a bit further down, you will also see very relevant hits, but still have some reactions on top that we actually don't want to see. And this is because for some types, very specific types of reactions, the mapping cannot be applied. So you will find some reactions that are in the database not having that reaction mapping. But to remove those from the answer set, you have the option to set a filter to the availability of reaction mapping data. And this can be found here on the left-hand side within the different filter options. And setting the filter to reaction mapping data available will retrieve a very relevant answer set with exactly what we have drawn, because now the system really knows what we actually wanted. In some cases, we also might want to exclude specific reagents, structural moieties, or catalysts from our reaction answer set. To do this, we can save our original answer set. I just call it to keep in this case. Click on Save. And then I refine to exactly what I don't want to have. So I refine to the criteria that I actually want to remove. In that case, I don't want to have any azides in our reaction. So we see here the reagent is diphenylphosphoryl azide, but I don't want to work with any azides. To remove or to refine to exactly those reactions first, I am going to use the structure editor that I can find within Search Within Results. Click on the Draw button, and I don't need to specify this too much. I just draw this with unspecified bonds and want to remove everything that includes a chain of 3 nitrogen atoms in a row. Of course, I then have to select the substructure search results, click on Find to refine the answer set, including sodium azides. So now we have all the reactions with any role including azides. We save this answer set again as to delete in this case. And now we can go to our saved answer sets and use the combined function to remove the answer set containing the reactions we don't want to have from the answer set that we want to keep. So I select the search type reactions and subtract the reactions that I called to delete. Click on View Results and will now see the reactions fitting to my search query, very relevant reactions, but not containing any reactant or reagent containing azides. Before we start planning this reaction, we can first have a look how much the substrate actually costs. So we can go to the suppliers, have a look at the costs, and 1 gram is already 275 British pounds here. So to develop the synthesis plan of a multi-step reaction, we can then click on that structure and that window will be opened. Here we see reactions, so all reactions with that substance and the synthesized reactions to synthesize with that compound as a product and develop our synthetic. So this would actually be the classical way how to create a synthetic plan if you are not using our new retrosynthesis planning functionality. And with that, I hand it over to my colleague Lena Blumenthal.